started on today's lecture. A couple of things. Number one, last week I did section 6.1, and we're moving on today on section 6.2, and we'll be also getting into 6.3 a little bit. Just to let you guys know, by this weekend, you got 6.1, 6.2, and 6.3 in terms of your homework that you can anticipate on Sunday night. So keep an eye on everything that's due, because we're getting towards the end of the semester. This is our last section. And so we've been talking about integration. And I just want to remind you of the rules that you have memorized. Now, the basic rules are basically this. When I integrate a derivative with respect to x, I get the original function back plus c. And for notation purposes, we also say that the integral of little f of x dx will give me actually big F of x, and with a plus c on it, okay? Now, in terms of rules you have memorized, with the integral of a constant dx was equal to what? These were my rules. What's the integral of a constant? Very good. Constant times x plus c. The integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. That's your big power rule. Integral of x cubed is x to the 4th over 4. Integral of x to the 1/2 is x to the 3/2 over 3/2 plus c. You can have any power except n. The power cannot be -1, because when it is, integral of x to the -1 dx is the same thing as integral of 1 over x dx, and that's equal to the natural log absolute value of x plus c. The integral of e to the x dx is equal to e to the x plus c. And the other two basic rules that we actually talked about were these guys. The integral of a constant times a function dx. Where do constants get to go? They go out front and they just hold over, and you're focusing on the variable. So that's equal to constant times integral of f of x dx. And the other one was the integral of f of x plus or minus g of x dx. That's equal to the integral of f of x dx plus or minus the integral of g of x dx. So when you've got a bunch of terms being added or subtracted, you integrate each term. Okay? However, there is no product rule, there is no quotient rule, and there's no chain rule for integration. What we have for that product rule, quotient rule, and chain rule for integration is what we're going to talk about today, and that is section 6.2. What we're going to do here is we're going to take these rules up here and we're going to rewrite them in terms of a different variable. This is called u-substitution, or substitution for lack of a better term, but we typically call it u-substitution because we use the variable u. So, watch this. Rules, again, just switching them over. The integral of a constant du. Integral of constant du is going to equal to a constant times u plus c. You're replacing the arbitrary x standard variable with the u. The next one is the integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. The integral of 1 over u du is equal to the natural log absolute value of u plus c. So this is your power rule formula, provided n cannot equal -1. And the integral of e to the u du is equal to e to the u plus c. So if you'll notice, all I've done is written the original forms that we memorized from last time and written them in terms of u. Now, what we're going to do is we're going to start integrating, quote, hard stuff. Okay? Things like this. The integral of ax plus 5 to the 6th power dx. This is an example. Okay? Now, how do I integrate this guy? I don't have a integral of 8x plus 5 to the 6th power dx memorized. Well, no, you don't. But here's the deal. With the appropriate u substitution, we can turn problems that are products, quotient, and chain rule looking type functions into one of these four formulas. okay? Now, first rule of u substitution is this. You gotta figure out what you're gonna let u equal to. It's a game of converting hard problems into one of these formulas. In this game, I'm gonna let u equal to the 8x plus 5 inside parentheses. That's your number one rule for u substitution. Let u equal inside the parentheses. Now, you notice when I'm talking about integration, that d, whether it be a dx or a du, does stand for something else. It means with respect to x, so you know what the variable is, it also stands for the derivative. So all that stuff from chapter 2 all the way up through chapter 5, it's going to come back and haunt you. Once you decide what du and what u is, then you got to find du. D means the derivative. I'm taking the derivative with respect to u. Derivative with respect to u is 1. I put a du to let me know that was a u variable. What is the derivative of 8x plus 5? It's 8. But you're going to put a dx over here to let you know you took the derivative of an x variable. Does that make sense? The du tells me this integral, the derivative of u is just 1 du. The integral 8x plus 5 is 8 dx. And the d is just telling me what the variable is. Now, this is called u substitution. The goal is to take a hard problem and turn it into one of these formulas you have memorized. Now, it's substitution. So what I'm going to do here, as I look at this problem, there's a dx in this problem. So I'm going to have to substitute for it. So there's my dx in the du statement. I'm going to move my constant to the other side. I don't care if it's a constant or a function. I'm going to move it to the other side because I'm going to figure out what I'm going to substitute in for dx. Well, to move it to the other side, this is being multiplied, so I'm going to divide by 8 on both sides. That's going to give me a 1/8 du is equal to a dx. I just moved my constant to the other side. Now here comes the game. Substitution. The integral stays there. This 8x plus 5 was what? That's what we let u equal to. Does that make sense? However, the dx gets replaced with 1/8 du. It's literally a substitution. And this is u, and it's being raised to the 6th power. So I want you to see this idea of substitution. This 8x plus 5 is u. You're still raising it to the 6th power. The dx got replaced with 1/8 du. Now I want to clean this guy up, but I want to see I'm literally substituting into this problem. Now, where do constants get to go when I'm integrating? Out front. So this would turn into 1/8 the integral of u to the 6th du. And if I did this right, it's going to turn into one of the formulas that I have memorized. And this is the u to the n formula. And now to integrate this, and when you integrate, the integral and the d stuff go away. You turn into this problem with the plus c. Integrals and d's go away once you apply the integral form. So 1/8 is a constant, leave it alone. What's the integral of u to the 6th? Add 1 over add 1, that gives you what? Times u to the 7th over 7. The integral and the d stuff go away, and you got a big old plus c on it. Clean it up. This is equal to 8 times 7 is what? 56. So it's u to the 7th over 56 plus c. And now here's the big deal in terms of your answer. The original question was in terms of x. Proper ethics of mathematics, if you start in terms of x, your answer's got to be in terms of x. So the last thing you do is back substitute, and then you got your answer. So what was u equal to? U was equal to 8x plus 5. So the answer is going to be 8x plus 5 to the 7th over 56 plus c. And you integrated something very hard and you found its antiderivative. Again, there's no product rule. There's no quotient rule. There's no chain rule for integration. For derivatives there are, but not for integration. What we have for integration is the number one technique, u substitution. And if you let u equal to something or other, du has got to be in the problem. And you've got to move your constant and maybe the function on the other side and clean it up, and it should completely turn into one of these forms that you turned into. This is what section 6.2 is all about, okay? So, we're going to do lots of practicing with this guy. So, here we go. Come over here to your notes. and get used to the terminology is what this first part's all about. It says this, integration by substitution, called u-substitution is the traditional name, okay? Under our learn mode here, integration by substitution restates the formulas of integration with the function notation by making u-substitution as follows. U would be equal to some kind of a function, gx, and then du is going to be the derivative of that guy, typically with a little dx on it, okay? Now, these are the rules I went over. Pure memorization, same rules as before. All we're doing is switching letters to get into that classic u-sub thing here. So the integral of k du is going to be equal to what? A times u plus c. Integral of u to the r du is going to be u to a power, you're going to add 1, u to the r plus 1 over r plus 1 plus c, where r cannot be equal to negative 1, because that created the next special formula. The integral of du over u, better yet known as the integral of 1 over u du, which is also u to the negative 1 du, is equal to what? Natural log absolute value of u plus c. And then the last of the 4 formulas of u-substitution you've got to have memorized is the classic, what's the integral of e to the u du? The integral of e to u is e to the u plus c. Okay? Any substitution made in an integrand requires a related substitution for the differential. And if you remember our words, u, this is my substitution. The du, that d stands for that differential. That is the terminology we use. Number 4, the u-substitution method should be used in order to check the correctness for the antiderivative. You must use the chain rule. That's typically it. Chain rule, but it could be chain rule or product rule or quotient rule. In this last one, people are going, what in the world is he talking about? Here's the deal. Remember, you can always check your antiderivatives. When you take the antiderivative and you get your answer, like, wait, this last problem right here. That problem we just did. I just made it up off the top of my head. We integrated this problem, I got this guy. How can I check my answer? You're going to take derivative of this guy. You take derivative of the answer, you get back to the question inside the integral d thing. Does that make sense? So if I took the derivative of this, the 56 pops out front. So this is 1 over 56, 8x plus 5 to the 7th. To take derivative of that guy, I'm going to use chain rule. The 7 pops out front, the inside stays same, raised to the 6, times derivative of the inside. And when you clean all that other stuff, plus derivative of constant 0, when you clean up all that stuff, you can get 8x plus 5 to the 6. That's what it's talking about. To double check this thing with this u substitution, typically you can use the chain rule to take derivative of it. But it's also some other things you can do, and you'll see that in just a second. There is no product rule for integration. So you would use it for that, okay? There's no quotient rule either, okay? So, a rule of thumb is this, all right? Now, this is our book, and I'm going to redo the order of this guy because I'm going to give you guys patterns to catch this thing. But here's our textbook. The rule of thumb is to substitute u for, number 1, they say is going to be the exponential exponent in an exponential function. So they say, number 1, you let u equal to the exponent in the exponential, okay? An expression inside, and this is what I call number 1, but they call it number 2, parentheses. You always let u equal to inside parentheses. That's what I just did in that last problem. That's one thing I want you guys to focus on, because I don't know, most of the problems you'll see is going to be some type of parentheses, okay? Okay. Or you let u equal to the denominator That's another thing you should let u equal to. And also an expression under a radical. You see the word radical sign. They're trying to give you an idea of what you're going to let u equal to in terms of these problems. Let me restate this over here in John's way. When I'm looking for a problem, first things first, I look at it and go, can I integrate this thing? Do I have these formulas memorized? You know, integral x squared dx is, yes, x cubed over 3. I can integrate that guy. I don't need any kind of special trick to do it. But when it's a problem that I can't recognize, it's not one of my basic forms, then I'm going to do this. I'm going to try this. Number one, I'm going to let u equal to inside parentheses. I'm going to use my little code here. When I got a parentheses in a problem, I'm going to let u equal inside the parentheses. That's traditionally the trick. Number two, I'm going to let u equal to the exponent. Typically, it's going to be on e's. When you've got an e problem, okay, you know, e to the 3x plus 2. That 3x plus 2, the exponent on that e is typically what you're going to let u equal to. Okay, there's going to be a pattern on this stuff. 1, inside parentheses. 2, exponent on e's. Number 3, I'm going to let u equal denominator. If I got a fraction, quotient, I'm going to let u equal to the denominator. Now, there's more to the story here. All right, let u equal to the denominator. Okay, so let u equal inside parentheses. Let u equal the exponent on those e's. Let u equal to the denominator. Now, they said there, let u equal underneath the radical sign. Well, here's the deal. I don't do radicals. What's a square root also known as? Something to the 1/2 power. And when I'm back to something to a 1/2 power, I got inside the parentheses. It'll be to a 1/2 power. So this is just an extension of inside the parentheses. Okay? So 1, you let u equal inside the parentheses. 2, exponents on e's. 3, you let u equal the denominator. And here's another one. Number 4, the catch-all phrase. Let u equal to something such that du is in the problem. That's the real trick of u-substitution. Up to a constant. You can always manipulate a constant around, but you always let u equal to something. When I take its derivative, it's going to be in the problem. That is the u-substitution technique right there. Whatever I let u equal to, du is going to be in the problem. Okay? Now you go, what happens if I let u equal something other than du is not in the problem? Don't worry. You know, there's a math class after this one for those folks that want to take it. It's called Math 2120. We'll teach you all about that stuff too. But most majors don't have to have that. But if you want to get into like double majoring or minoring in math, you got to go to Math 2120. We get into deeper in this stuff. It's not going to be in our course. So whatever I let u equal to in here, du is going to be the problem. All right, so pay attention to this stuff. So here we go. Oh, one more thing. Little John note here. Never let u equal x in a u-sub problem. It is stupid. Okay? Now, what is the point of u-substitution? The point of u-substitution is to completely change the problem into one of these forms that we have memorized. Okay? If I let u equal x, then du equals dx. It really doesn't change the problem at all. For example, see this guy right here? Remember, the integral of 8x plus 5 to the 6th power dx. If I let u equal x, how would that change? Well, then it would turn into the integral of 8u plus 5 to the 6th, and derivative of u is 1 dx, so the dx turns into a du, and it actually turns into the integral of 8u plus 5 to the 6th du. Does that really help you out at all? No, it's the same problem, you just change the letter. We're not trying to change a letter, we're trying to change the function to something that we have memorized, so we can apply the integral rule. That's the goal of u-substitution. And it's the #1 technique of integration. Because now you guys are going to begin to integrate hard stuff. Let's take a look at this first example right here, the famous hawkstv.com problem here, okay? So we want you to integrate this guy. The integral of 4x plus 10 over x squared plus 5x plus 2 dx. This is not a rule I have memorized. So when it's not a rule I have memorized, it should take you like a half of a second to look at it and go, this one I don't have memorized. Then you should try u-substitution. And here we go. #1, I'm going to let u equal inside parentheses. You see parentheses on this thing? Nope, me neither. #2, I'm going to let u equal to the exponent of e. You see an e in this problem? Nope, there's no e's in this problem, so throw that one out too. Then #3, I'm going to let u equal to the denominator if I get a fraction. Do you see a fraction? Yes, I do. So in this problem, I'm going to let u equal to the denominator x squared plus 5x plus 2. The denominator. Then, step 2, take d. You want steps? I give you steps. Step 1, find u. Step 2, find du, the derivative. What is the derivative of x squared plus 5x plus 2? 2x plus 5. Put a little parentheses around it and put a dx on it. That's just to denote the fact that you took the derivative with respect to x variables, and it does going to substitute into your integral, which has a dx on it. Okay? So now, here we go. Look at this problem. This problem is the integral of 4x plus 10 over x squared plus 5x plus 2 dx. That's what we started with. Now, I see the u is the denominator because I started with that, but what do you got in common? I mean, clean it up. It's always a rule even before you integrate. Look at that numerator, 4x plus 10. What do you got in common on that thing that you can factor out? A 2. I can factor out a 2. And where do constants get to go? In front of the integral. So this would be 2 times the integral of factoring out the 2. I would be left with out of the 4x plus 10, I'm left with a 2x plus 5 divided by x squared plus 5x plus 2 dx. All I did was take a 2 out of the numerator. And I wanted to do that because, remember, whatever I let u equal to, du has got to be in the problem. And once you factor out the 2, you get to see, there's my du right there. So now that I'm going to substitute, this turns into 2 is a constant, it holds over. Integral, this is a division problem. The denominator was u. What is the 2x plus 5 dx going to turn into? 2x plus 5 dx turns into du. You get to substitute in for 2x plus 5 dx in terms of du. And we always stick the du in the back. Let's put him in the back. You can put him in the numerator if you want to, but typically it's put in the back. And because everything got substituted, you always have a 1 for replacement. Because I put him in the back, it's 1 du. You can also put him in the numerator, but to put it into an integral form, it's an integral of a function with the d in the back. Now, look at this guy. As I substituted it, it should turn into a formula that you have memorized. 2 is a constant. I ain't worried about him. What's the integral whenever u du? Natural log what? Absolute value of u. So this would be, when you integrate it, this is the whole purpose, was to turn it into a rule we could memorize. This is 2. The integral 1 over u du is the natural log absolute value of u plus c. And what's the last step of u-substitution? The original problem was in terms of x, therefore your answer has to be in terms of x. Back substitute. So this is equal to 2 natural log absolute value of u, but u was the x squared plus 5x plus 2 plus c. And there's my answer. Does that make sense? Remember, clean it up. You got a constant in common, factor it out. It's fine. But let u equal to 1 inside parentheses, 2 exponent on these, 3 the denominator, and then the catch-all phrase. Let u equal something says the du's in the problem. All right? Try this guy here. Let's do some practice problems. Use the technique of substitution to perform each integral. The integral of 1 over x plus 6 dx. You got this one memorized? Nah, me neither. So what are you going to do? Use substitution. Here's my list. Do you see inside parentheses on this one? I don't see any parentheses. #2. You see exponents on this one? E to the exponent? Nope, no, so U is not gonna be the exponent of an E. Number 3, you see a fraction? Yes, so what am I gonna let U equal to? The denominator, x plus 6. Then, take du. First, find u, step 1. Then 2, find du, take derivative. What's derivative of x plus 6? 1 dx. Always put the d on there to let you know what variable it is, because you know we're going to switch to t's before too long. It doesn't matter whether it's an x or a t. Take derivative of it and put a d whatever. Keep this in case dx. Now substitute. So this problem is an integral. It is a division problem, so you don't change the essence of the problem. But u was the denominator, and the 1 dx gets replaced with du. We typically put the du in the back and leave the constant 1 right up there in the numerator. So this thing, what a surprise, just turned into the classic form of 1 over u to u. I mean, there's only 4 forms we're going to turn this stuff into. So let's do 1 over u to u again. Natural log, absolute value of u plus c. That's my formula that I have memorized. And now the integral and the d go away. You get the function plus c. And then the last thing you got to do is back substitute. What was u equal to? So the answer is going to be natural log absolute value of x plus 6 plus c. And on Hawks, you've got to put in these little absolute values. But when you go to your little template thing, the little absolute value icons will show up there. Click in there and put x plus, and that's a 6. If you can't believe my handwriting there. There you go. Does that make sense? There's my solution. All right, so they're going to try to turn up the heat a little bit. Try this one here. Integral of 3x to the 8th plus 6x minus 4 to the 1/3 power times 24x to the 7th plus 6 dx. All right. Is this a rule you got memorized? Yeah, me neither. Now, number 1, you're going to let u equal to inside parentheses. Since this is not I have memorized, you should automatically think u-substitution. It's not a rule I have memorized. What I'm going to let u equal to? Number 1, inside parentheses. Problem is, I got 2 sets of parentheses. Which one are you going to use? Typically, you let u equal to the harder, or one with the biggest power. But in this problem, it's pretty obvious which one you should let u equal to. If you read the problem, you got 3x to the 8th plus 6x minus 4 raised to the 1/3 power times the 24x to the 7th plus 6 dx. Well, since you've got this 1/3 power, and this is the 3x to the 8th plus 6x minus 4 is a bigger, larger degree than the other parentheses here, you're always going to let u equal inside the parentheses, and you want the bigger parentheses, the one that's actually being raised to a power. So in that case, the one that's being raised to the power, u is going to be 3x to the 8th plus 6x minus 4 inside the parentheses. Step 1, you got to find u. And here's the real kicker. Whatever you let u equal to, du up to a constant has to be in the problem. What's the derivative of this thing? What is du? What's the derivative of 3x to the 8th plus 6x minus 4? Derivative of 3x to 8, 3 is a constant. Derivative of x to 8, bring down the 8. 8 times 3 is what? 24x to the, subtract 1, 7, plus derivative of 6x is 6. Put a little parentheses around that. Times, and derivative of minus 4 is 0 with that dx. And you will happen to notice that what I let u equal to, du, up to a constant, has got to be in the problem. Do you see a 24x to the 7 plus 6 dx in this problem? I sure do. That's the rest of the part right here. So now I let u equal to the 3x to the 8th plus 6x minus 4. So du equals 24x to the 7th plus 6 dx. So when I substitute, the integral stays. This was du. And what are we doing to it? We're raising it to the 1/3 power. And the rest of it, the 24x to the 7th plus 6 dx is going to get replaced with just a du. And it simplifies the problem nicely. And it turns into a form I can integrate. What is the integral of u to the 1/3 du? Well, this is a classic u to the n du. Add 1 over add 1. Yeah, I know it's fractions, but you can deal with it. This is equal to integral u to the 1/3. Add 1 to 1/3, what do you get? U to the 4/3 over 4/3 plus c. 1/3 plus 1 is 4/3. U to the n plus 1 over n plus 1 plus c. Clean them up. When I divide by a fraction, what do? Multiply by reciprocal. Invert and multiply. So this turns into 3/4 u to the 4/3 plus c. And then the last thing you're going to do to get your answer is back substitute. The original question was in terms of x. Your answer's got to be in terms of x. So this is 3/4 times 3x to the 8th plus 6x minus 4. That's your u, raised to the 4/3 power plus c. That is my answer. Does that make sense? All right. Before I do this one, I want to do another one. So I made up my own problems here. So put a little star right here. I'll make up my own problem. All right, you got to pay attention to these guys. So I want to do this problem right here. I want you to integrate x times e to the x squared plus 3 dx. So I'm going to come over here and blow this one up here to the side of the page. I'm creating a new problem for you guys. I want to integrate x e to the x squared plus 3 dx. This is not a rule I have memorized. I got integral e to u memorized, no problem. That's the easiest one in the world, e to the u plus c. This isn't e to the u. Or is it? With a u-substitution, what are you going to let u equal to when you got an e in the problem? Right. And again, if I let u equal to the exponent, x squared plus 3, then I'm going to take du. What is the derivative of x squared plus 3? 2x what? dx. Don't forget the d, so that you know your fingers affect x. Now, you can always move a constant. Multiply or divide, you can manipulate constants, is okay. Now, look at the problem. Once you let u equal to the exponent, this function is going to turn into the integral of e to the u, because you let u equal the exponent on e. What about the rest of it? What is this x dx going to turn into? Well, du is equal to 2x dx. You can solve for the x dx by doing what? Divide by 2 on both sides. You can always move the constant over. So I end up getting 1/2 du equals x dx, which is in the problem. And when I substitute it, the 1/2 being a constant, I'm going to put in front, and I always put the du in the back. Now, when you look at this problem, this is the deal. When you integrate with u substitution, the original problem should turn into nothing but a u formula, maybe a constant out front and a du in the back. You don't have any plus something or others or minus this, or you just basically, it turns into one of your basic forms. Now, apply the integral form. So this is equal to 1/2. What is the integral of e to the u du? E to the u plus c, that's applying my formula. And then the last thing I'm going to do is back substitute. This will be 1/2 e to the u, which is your x squared plus 3, plus c, and there's my answer. Now, this is a traditional that u equal to the exponent kind of problem. This one over here, they're trying to mess with you. So that's why I wanted to do this one first. Take a look at this problem. This is the integral of -4 e to the -6x divided by e to the -6x plus 6 dx. You're looking at this thing, well, wow, there's u's everywhere, and there's denominators. Which one should I use? Well, if I let u equal to the exponent on the e, going through by hierarchy, that's fine. Then the u would be -6x. Derivative of that would be -6 dx, and you can move the constant aside. So, but this becomes e to the u. So it'd be -4 e to the u divided by e to the u plus 6. Do you actually guys know what the integral e to the u divided by e to the u plus 6 is going to be? That's not a rule I have memorized. The purpose of u substitution is to turn it into a formula. And because this guy happens to be a fraction, try this. Let u equal to the denominator because it's a fraction. Again, the goal is to turn it into a form that you have memorized. If I just substitute in for the e to the x, it turns into a different formula, but it's not one I have memorized. If I let u equal to the denominator, my denominator is e to the negative 6x plus 6. Then what is the derivative? All right, let's go through our rules. You just had a test on it not too long ago. Well, derivative of e to the x is e to the x. Derivative of e to a function is e to the function times derivative of the exponent. So here we go. Derivative of e to a function is going to be e to the function, e to the negative 6x times derivative of the exponent. What's derivative of negative 6x times negative 6? Plus the derivative of 6, being a constant by himself, is 0 dx. Does that make sense? And so when you convert this guy over, this is an integral, this is division, this was u in the denominator. Now, if you look at this guy, you'll see there's an e to the negative 6x right there. And there's a dx part. So I'm going to solve for that guy. So I'm going to move my constant, like I did over here, to the other side. This is being multiplied by negative 6. I'm going to divide both sides by negative 6. This gives me negative 1/6 du is equal to e to the negative 6x dx. And that's in the problem. So I'm going to substitute e to the negative 6x dx with a, I'm going to put him right here, negative 1/6 du. So the e to the negative 6x dx is gone, it's negative 1/6 du. However, that negative 4 is a constant. Never got to substitute. Constants going from one integral to another is going to hold over. Just hold your constant. Typically it goes out front anyway. It's not part of the x, trying to convert it over problem. But now you want to clean this up. Multiply your constants together. What is negative 4 times a negative 1/6? What's a negative times a negative? Positive. What's 4 times a 6? 4/6, also known as 2/3. And constants get to go where? Out front. So this becomes 2/3, the integral. This is a division problem with u in the bottom, and the du is in the back. And when you pull your constant out front, you're always going to multiply it times 1, put a 1 in the numerator. You either pull it in the back or pull it in the front. If everybody's gone, you still got a 1 for placement. And it should turn into a formula that you have memorized. Okay? Now, what is the integral of 1 over u? Now, 2/3 is a constant. It holds over. What's the integral of 1 over u du? Things we have memorized. Natural log, absolute value of u plus c. And there's my answer, but here's my problem. About 5 of you people in here, because you're running through these things so quickly, you're going to circle this answer, declare victory, move on to the next problem. Well, you fumble the ball at the goal line. What did you do? What's the last thing you do to any u substitution problem after you integrate it? What do? Back substitute. Remember, the original question was in terms of x. I'm expecting an answer in terms of x. So back substitute, this will give me 2/3 times the natural log of the absolute value of u, but u was this e to the negative 6x plus 6, close absolute value, plus c, and that is my answer. Remember, the ultimate goal of u substitution is to convert the problem into a formula that you have memorized. And you're thinking, well, there's 10,000 formulas I have memorized. No, there are 4. Okay, it's got to convert into one of these guys. A constant du, u to the n du, 1 over u du, or e to the u du. It's going to convert into one of those guys. You may have some constants out front, but constants will just hold over. Okay? Look at this guy here. And I just want to show you this one. I want to rewrite it because rarely they do this to the problem. Usually they do this. The integral of 6 over 5x plus 3 to the negative 2, that becomes a positive 2 what's on the bottom, a dx. Okay? Usually they write it in terms of, 6 over 5x plus 3 squared dx. Okay? If I was going to do this problem, what's the first thing you try to let u equal to? Quote, inside parentheses. And if I let u equal inside the parentheses, this is a set of parentheses that's being squared. So u would be inside the parentheses, the 5x plus 3, okay, inside the parentheses. So what would du be? What is my derivative? 5 what? dx. Don't put the d on there. And what do? Constants get to move to the other side. Move your constant. That gives you 1/5 du equals a dx. So when I convert this problem over, this will give me the integral over, this was u inside the parentheses, and the power stays there, u squared, and there's 6 stays on top because it's just a constant, but the dx gets replaced with 1/5 du. And I'm really just trying to emphasize the word u-substitution. We're substituting these parts of this problem. Now, clean this guy up. What is 6 times 1/5? 6/5. And where do constants get to go when you're multiplying times a function? To the front of an integral. So this becomes 6/5, the integral. Now, you can write them as 1 over u squared du. And I wanted to show you this because a lot of people are going to do this. And they're going to tell me the integral of 1 over u squared du is the natural log absolute value of u squared. And you just violated 45 rules of math. There's only one rule for natural log. It's 1 over what? U, not u squared. So anytime you got something in the denominator, how are you going to clean it up? You bring it to the numerator and you make the exponent what? Negative. And that's where you get this guy from. This becomes 6/5, the integral of u to the negative 2 du. Again, any power other than 1. 1 over u is a rule. 1 over u to a power is not a rule. You got to clean him up to turn him into the famous u to the n rule. Now integrate. Add 1 over add 1. So this becomes 6/5 times add 1. U to the negative 2 would be add 1. U to the negative 1 over negative 1 plus c. Let's clean him up. Positive times, well, 6/5 divided by negative 1 is negative 6/5. U to the negative 1 plus c. But now, here's the deal. Where's the negative exponent put you? If it's on top, where's it going to put you? To the denominator. So this becomes negative 6 over 5 u to the first power plus c. And one last move. What's the last thing I'm going to do to get this answer? Back substitute. So this would be equal to negative 6 over 5 times u. And u was 5x plus 3. 5x plus 3. Close parentheses. It's proficient to the first power plus c. And there's my answer. Does that make sense? It's not hard, but you do have to manipulate the arithmetic to get it into the form. Okay? Questions? All right. Take a look at this guy here. You'll notice that they're turning up the heat on these problems. All right. The integral of negative 2, oh no, they threw a different letter at you. Who cares? The integral of negative 2y times the square root of 3y squared plus 5 dy. First rule is this. I don't do square roots. What's the square root also known as? Half a power. So this turns into the integral of negative 2y times 3y squared plus 5 to the 1/2 power dy. Not a rule I have memorized, so u-substitution. What are you going to let u equal to? Inside parentheses, which is your 3y squared plus 5. Step 1, clean it up the problem, and then find u if it's not a form you have memorized. Then take du. What's derivative? What's derivative? 3y squared plus 5. 6y dy. I see the y dy, move your constant to the other side. So I'm going to divide by 6 on both sides. This gives me 1/6 du equals y dy. And this is the purpose of constants hold over, but I want to substitute in for the y dy because that's what's left over. Constants, I don't worry about. So this becomes the integral of u to the 1/2. Negative 2 is a constant. You can pull him out front, just hold him over. The y dy gets replaced with a 1/6 du. Now I'm going to put all my two constants together that are being multiplied. What is negative 2 times a sixth? Negative 2 times 1/6 is what? Negative what? 1/3. Very good. I'm going to pull that front. Negative 2 times the 6 is a negative 1/3. The integral of u to the 1/2 du. The constant holds over, always out front. This is negative 1/3. Now, what's the integral of u to the 1/2? Add 1 over add 1. A half plus 1 is 3/2 over 3/2 plus c. Clean them up. This will be equal to negative 1/3 times. When you divide by 3/2, you invert multiply by 2/3. U to the 3/2 plus c. Clean it up. Nothing cancels here, so this gives you what? Negative 2/9 u to the 3/2 plus c. And then what's the last thing I'm going to do to this problem? Back substitute. So what is my final answer? Negative 2/9 times u, which is 3y squared plus 5 to the 3/2 plus c. Look at the next one. The integral of 3x cubed minus 2 divided by 3x to the 4th minus 8x plus 8 dx. Do you see in parentheses this problem? No. Do you see any exponents with an e on it? No. Do you see a fraction? Yeah. What are you going to let u equal to? The denominator. The denominator is 3x to the 4th minus 8x plus 8. Then you take du. What is the derivative? What's the derivative of 3x to the 4th? 4 times 3 is what? 12x cubed minus derivative of 8x is 8. And put parentheses around it with the dx on it. Now, look at this guy and think about your problem. What do you have in common that you can factor out of the 12x cubed minus 8? What do they got in common that you can factor out? A 4. I can take out a 4. So du would be equal to 4 times. The factoring out a 4 out of a 12x cubed gives you with a 3x cubed. Minus factoring a 4 out of an 8 is a 2 dx. And pay attention. That's in the problem. Move your constant to the other side. Whatever you let u equal to, du's got to be in the problem, up to a constant. So I'm going to divide both sides by 4. That gives me 1/4 du is equal to this 3x squared minus 2 dx, which is right there in the numerator. So when I substitute, this is an integral. This was u, which is the denominator, and the 3x cubed plus minus 2, 3x cubed, I can do that 3 there, 3x cubed minus 2 dx, it gets replaced with 1/4 du. I'm just going to pull them out the back, 1/4 du. Always got a 1 for placement. But clean them up before I integrate them. Where does my constant get to go? Out in front. So this turns into 1/4, the integral of 1 over u du. And that's pure memorization of formulas. 1/4 holds over. What's the integral of 1 over u du? Natural log absolute value of u plus c. And then I back substitute 1/4 the natural log absolute value of u. U was 3x to the 4th minus 8x plus 8 plus c. And there's my answer. Back substitute. Take a look at the next guy. The integral of x minus 2 to the negative 6 dx. What are you going to let u equal to? Because it's not a rule I have memorized. Inside parentheses. Inside parentheses is x minus 2. What's du? What's my derivative of x minus 2? 1 dx. So when I substitute, this becomes integral. This one, x minus 2 is u. You're raising it to the negative 6 power, and the dx gets replaced with du. Now integrate it. Integral of u to the negative 6, add 1 over add 1. That gives you u to the adding 1 gives you negative 5 over negative 5 plus c. Does that make sense? You've got to know your basic rules. U to the n, du is u to the n plus 1 over n plus 1 plus c. If you want to, you can back substitute here. This would be u was x minus 2, so it would be x minus 2 to the negative 5 over negative 5 plus c. And that's perfectly allowed, but honestly, we like to clean this stuff up. Where does a negative exponent put you? Denominator. So this would be 1 over negative 5 times x minus 2 to the 5th plus c. That's the better way for it to look. Does that make sense? We've got a few more, but this is great practice. You need to go through and practice these problems, because it's a very important technique of u-substitution. And then we'll finish up these next time, and then go on into section 6.3. So study hard, and I'll see you guys then.